by example tool, and we'll take a few minutes to look at that again before we get into SQL. All right. First thing that we did last time, just to reiterate, and I think it's important to always remember this. Not put the cart before the horse, as they say. Remember what our goal is here. Our goal is to take raw data and transform it into something usable, transform it into information. And, we design the best way to store the data to eliminate redundancies for the most flexibility. But we're not just putting the data in there and keeping it there, right? We need to have it come out, and we need to have it come out and be displayed in a flexible manner. And that's really what queries are about, taking data out of the database and displaying it in a flexible way, as flexible as possible, to give as many options as possible to the user. The query by example tool that we looked at sort of allows you to graphically create the query. All right, and we did a few queries last time. Let's do a couple more today, just to be sure that we have the hang of it before we come into SQL. You can go under Create and Query Design. And let's say I wanted to know every faculty member who had an office in the business division, in the business building. All right? So we can ask for faculty and location. So we can pull stuff from more than one table. If we've defined our keys and everything correctly, then Access's query by example tool should link the tables for us already. All right. If you notice, there's a line between the two tables. That's because we've set up the foreign keys. All the tables in your query do need to be linked to each other. Let's bring another table in. Let's bring in the faculty rank table. All right. Notice how they form a chain. Let me rephrase what I said a minute ago. I said all the tables need to be connected to each other. That's not necessarily true. In other words, the location and faculty rank aren't connected to each other, but they are connected through the faculty table. So there needs to be a chain of all these. And we'll look at what happens if you don't have that connection in a minute. Once we have joined these tables, we can then go in and specify what we want to see in the query. So, for example, I wanted to see the faculty person's last name, let's say, first name, the description of their rank, their building code, and finally the room number that they inhabit as their office. And if we run this, what it will do is it will connect everything together. For each faculty person, it will show the description of their rank. If you remember, throughout the whole process of database design, we talked about all those code tables where, for example, pizza, we had a code table for pizza size. We had a code table for the type of crust. We had a code table for delivery type, whether it was delivery or pickup. All those things in the main table, we were just storing the key, and we stored a description elsewhere. Through these queries is how we can take the data from the tables and combine them together so that we can see, associated with the faculty person, not the code of their faculty rank, but the actual description of the faculty rank. Not the ID number of the room that they inhabit, but the actual building code and room number. So if I run this, we'll see these four faculty people are here. All right. If we want to filter, I said originally we wanted to see only those people whose office was in the business division. We could go in and say where the building code in the location table equals BUS. And we should enclose that in quotes because we want it to be exactly that value. If we run that, then it only shows those two faculty people. So, to kind of summarize this, we've joined tables together. All right. Again, if you've defined the foreign keys correctly, then Access will join the tables for you. All right. So that shouldn't be a problem. We have filtered data. In other words, we went through and we chose to see not just every faculty member in their office, but just those folks that are in the business building. So we can filter data. Another thing we could do is we could summarize. For example, let's actually get rid of these. If I wanted to see how many faculty people were in each room, I could go by totals, group by building, and count the number of rooms. And it would show me that there's 2 faculty people in the business building and 2 faculty people in the library. So we can do, in essence, all those things that I talked about when I talked about how do you transform data into information, right? We said you can combine stuff together. Well, we joined tables together, and we brought it together to take that raw data and put it in a usable form. All right? We filter data. That is, we can look not for everyone, but only people that meet a certain criteria. All right? We summarize data. In other words, we didn't see everyone, but we just want to see maybe totals. We don't want to see necessarily every professor. We just want to see totals broken down a certain way. So those are most of the main things that you want to do when you want to get data. Remember, we talked about a library, not wanting to see every book that was ever checked out, but filtering by only to see only the ones that are overdue. The other thing that we didn't talk about, I'm going to go back to design view and actually get rid of the totals, and I'll put back the faculty last name, first name, and rank, is we can actually sort and organize it. So we can sort by the faculty name, or we can sort by the office and room, or the building and the room number, or whatever criteria we wanted to, sort by faculty rank. All right. So all these ways are ways to take this raw heap of data and transform it into something that's more usable. And depending on what you need, all right, you could write a query to produce it. A query that will filter out, that will combine things, that will sort things, that will organize things, or even will summarize things and give totals. All right. One thing I wanted to demonstrate. This is something, pay attention. All right. Write this down or whatever. Otherwise, make sure you remember this. I want to talk about the symptom of what happens if you don't properly join the tables together. All right? This query is properly written, and if I run it, I get 4 faculty members. And I can look, and sure enough, there's 4 faculty members in the faculty table. All right? Watch what happens if I don't join these tables together. I'm going to go in and undo what it did for me naturally. So if there's no line between the 2 tables, if they're not joined together. When I run this, my 4 faculty people transforms to a whole bunch of faculty people. And if you notice, it repeats. In other words, John Blanchard is repeated, a goodly number of times. Philip Brown is as well, and so on. What that does is, that's what's called a cross product. And the way the cross product works is like this. If you don't specify how to connect 2 tables together, it matches up everything in the one table with everything in the other table. I swear, I went upstairs before class to get a pen, and now I can't find it. We'll use this one. So let's say we have this. We'll just do we'll do the faculty matching up with the building or with the room code. Let's say we have a faculty table that has faculty number 1 is Mike, whose office is in office ID 1. Faculty ID 2 is Paul, whose office is 3. Faculty 3 is Don, whose office is 2. And finally, faculty 4 is Doug, and his office is 5. So let's say that's the faculty table. And this is a faculty ID, that's the name, and this is the location ID. And in the location table, we would have maybe location ID of 1, 2, 3, 4, 5 with the room numbers associated with them. All right. If we don't connect and we don't specify in the query how to match up the two tables, what it does is it will match every faculty person with every room. All right, with every location in this case. And so in this case, if there's 4 faculty people and there are 5 locations, my query will show 20 different combinations. It will show the same faculty person duplicated 5 times, all right, once for each room. Now when we throw in faculty rank, if there's another so many faculty ranks, we multiply by whatever that is to get the total number that it's going to show. So we have to specify how to match it up, because if we don't, it assumes everything matches with everything. All right? How do we know we've matched things up? Well, in the case of our query by example, if there's a line between the tables, we've matched them up. So if we run this, none of the tables are matched up, we get 312. All right? 312 would be how many faculty people we have, that's 4, times how many faculty ranks we have, 1, 2, 3, 4, 5, 6, that's 24, times how many locations we have, 13. So if we took 24 times 13, that would give us a total number of rows that are showing up in this query, which is 312. All right? Now, watch what happens if I join 2 of the tables, but not the 3rd. We're down to 24. Finally, if we join all 3 tables together in a chain, we're down to the proper 4. So even though we've defined the foreign key, we still have to, in our query, connect those. All right? Now, access query by example, by default, will connect it for us. Okay? So that's good. But we still have to go in and make sure that all our tables are connected. Now, when we write our SQL statements, we're not going to have that luxury of it doing it for us. We're going to have to know, and we're going to have to connect them ourselves. But that's one thing to keep in the back of your mind. If you ever run a query in SQL, whether it be query by example or a SQL statement that you've written yourself, and you end up with like way more rows than you'd expect, like many times the number of rows that you expect, you probably forgot to join some tables together. All right? There are a few specialty queries that it's a good idea to use the query wizard for, because without it, it's kind of tricky. There is, for example, the simple query wizard, I'd just as soon make it from scratch. Find duplicate query wizard, find unmatched query wizard are 2 that are very valuable. The find duplicate will find exactly that. Like, maybe I'm worried I have the same person in the database twice. Let's go in and let's name. Let's put Philip Brown in here twice. All right. I can run a duplicate query from the faculty table. And I can say, well, the fields that might contain duplicate information are the first name and last name. And What else do I want to see? Maybe I want to see their faculty IDs. Next, finish, and it shows me that I have 2 Philip Browns there. So that comes in very handy in validating your data. If you're concerned that maybe you've entered duplicate a product in there twice or something like that. This especially comes in handy if you're doing some sort of data conversion. In other words, if you're taking an Excel worksheet and going in and bringing it into Access. All right, you can import Excel worksheets into Access. Sometimes when you do that, though, because of the limitations of Excel, you end up with duplicate rows, duplicate data. Well, this allows you to help identify those, and then you can do some cleaning of the data. All right. Another thing that's good is there is a unmatched query. All right, and the unmatched query allows us, for example, to see if there are any faculty members that do not have any students assigned to them as advisees. So I could say, I want to see faculty that don't have any students associated with them. And again, it sort of knows how to connect them, so it did this right because we've defined the foreign key and all that. And maybe I want to see, this information about the faculty, their ID, their last name and first name. And then when I run this, it shows us that, well, the 2 Philip Browns don't have any faculty people assigned to them. Or, I'm sorry, don't have any students assigned to them. So I could do this to find rooms that don't have a faculty person assigned to them. Well, I don't know if that would be very effective because, classrooms don't have faculty people assigned to them. But I could do this to find faculty people that don't have any classes assigned to them or students assigned to them. Students that aren't registered for any classes I could find by doing an unmatched query. For those kind of very specialized queries, the query wizard comes in very handy. Because you could write those queries by hand, but the wizard's nice for those. The other thing that you can do, and I don't know if we have any data that this would work well for, is there's a crosstab query that kind of takes and creates sort of a spreadsheet-like thing. So, for example, I could look at faculty, and show the last name, and then actually, let's try this. Okay. All right. What this does is this shows us in the business building. Let's see. Oh. Actually, I think this is not a very good example, but essentially what it shows us is that there is one room in the CR table that, or in the CR building that has a capacity of 150. I don't think I created this correct. This is most useful for doing like sums and creating, like if you had a table you could sum up and show and create a spreadsheet like where you'd show by month the sales or something like that. I'm not sure if there's a crosstab query assigned or not. If there is, you should be able to play around with it and let me know if you have any questions. Because this database really doesn't have any good tables to do it for. I tried to do it with the location, but that didn't work out too well. All right. But usually if you're like summing up like sales by month, by customer, let's say, that's what a crosstab query is meant for, where you would have like going down the side, going down the page, maybe the customers. and then going across the top the months. You know, January, February, March. And to show the total sales for each of those. That's what a crosstab is typically good for. All right, now, we've been writing SQL statements all along. All right, we've just been using the graphical tool to create those SQL statements. We can even see the SQL statements. For example, let's look at one. Let's look at the Eau Claire students query. If you remember, what this did is we showed each student their faculty advisor and the faculty advisor's office for every student that was in Eau Claire, Wisconsin. All right. If we go to SQL View, we can see the SQL statement that was generated. All right. And it looks something like this. Now, the reason you have two options is, again, there's some people using Access that are not experts in database design.
Is cold in here?
I'm not.
There goes a complaint.
Not by me.
I got the call to come over here and check the temp. You guys okay?
What is that thing? Looks like a ray gun or something.
Yeah, it works. It's got, I can get the temperature of the room, whatever, you know.
Oh, cool. Can you see if if I'm running a fever or anything?
No, I don't think
Okay. All right.
I can get the body.
Yeah. Okay. Yeah, but no. And there's I know it's fine.
Okay. A couple more.
I apologize for the online class for the interruption. Someone's coming to check the temperature of the room. Apparently earlier today there was a complaint about the temperature of the room. And it was kind of hard to tell what was going on because he has this really cool like ray gun thing and he's going around going and oh look, with a little laser pointer. Nice. Oh, I see. All right, cool. Cool. All right, anyhow. That's all right. Anyhow, back to the queries. We can see the SQL statement that gets generated here. And again, the typical person that might be using Access isn't necessarily a database guru, isn't necessarily a database expert. All right? And therefore, the query by example is pretty straightforward. The ins and outs might take a little bit of practice, but you can get someone writing queries using the Access query by example pretty easily, as opposed to SQL, which is somewhat difficult to learn. Isn't that tough, but it takes a little longer to learn SQL than it learns query by example. You know, we spent a class and a half on query by example, and you folks probably know it as well as I do. All right. Now when we go into SQL, it's going to take a lot longer to learn that. That begs the question, why are we putting ourselves through this pain? If we can get queries through queries by example in a very simple, straightforward way, why would we bother learning SQL? Any ideas on that? I know you guys are like, yeah, why are we learning this? I'm getting out of here. The reason is again, this works within Access. But if we want to incorporate into our other applications SQL statements, we have to know how to write the SQL statements ourselves. For example, let me Google. Let's see if I can find a sample, a code sample out on the web that is going to look for, that's going to be a PHP page, which is a web programming language. All right, here's an example. This is PHP code. This is the programming language PHP. All right. We want our programs, whether they be web applications or desktop applications, they need to integrate with the database. Therefore, we have to build SQL statements inside of those applications. Right here is an example of a SQL statement. All right, this line right here. Specifically what's between the quotes. Select star from persons. That's an example of a simple SQL statement. So, if you're going to develop any kind of applications, you're going to need to include in those applications, or you're likely to need to include in those applications, SQL statements. And therefore, you need to know how to write them yourself because you need to include them as part of your program. And PHP is one example, but I just as well could have picked an ASP.NET example, or a Java example, or a C# example, or a VB example. So, in this class, in addition to learning sort of the end-user tool, the query by example, that doesn't require particularly too much expertise, we're going to learn how to write our SQL statements by ourselves. Okay, let's start out with doing simple SQL statements that just involve one table. All right? And for this exercise, I'm going to use the faculty table. I'm going to use the student table. And let me write some of the attributes of the student table down on this sheet of paper so that we can refer to it. There's the SID, which is the student ID, which is the primary key. There's SL name, SF name. All right, there are, I'll skip a few columns. There is S city and S state. And we'll skip the rest of the columns. We'll start out just looking at these columns. All right? We're going to emphasize in this class the SQL queries that actually return a set of data. Actual queries, as opposed to insert, update, and delete statements. There are SQL statements that allow you to insert a new row into a table, or to delete a row from a table, or to update a row. We'll talk about those, but our focus is going to be on the select statement, because the select statement is what's used to create queries. Now, the select statement really is probably the most involved of all the SQL statements. It has the most options associated with it. So it makes sense to spend the most amount of time on that. All right. Here's the most basic form of a SQL statement. And we'll do pretty much what they did in the PHP example, except we'll do it for our table. All right. A simple select statement will look like this. Select star from student. Now let's analyze what that does. All right. All SQL queries start with the word select. So if I ever ask a question, all right, let's write this SQL statement together. What's the first part of it? Raise your hand and yell select, then you're off the hook. All right? Because you got the easy one, and let everyone else figure out the harder ones. So all SQL queries start with the word select. All right? Following the select, there is a list of columns. All right? Now, you don't see a list of columns here, you see an asterisk. An asterisk is simply a wildcard or a shortcut that means all the columns. All right? So we have the word select, we have the list of columns, and an asterisk represents all the columns. We then have the word from, and then we have the table that we're selecting from. Now our first examples, we're going to do, probably all the examples we do today, we're going to do with just single tables. All right? Next week we'll pick up on actually joining tables together. All right? So, which students will I see? I'll see all of them. All right? Because I haven't specified which students I want to see. All right? I've said I want to see all the columns from the student table. Now, I can go in and I can run this query in Access if I want. What I'm going to do is I'm going to type, it might be a little hard to see on the screen, but I'm going to type exactly what you see here into an Access query and run it, and we'll see what we get. We'll go to Query Design. I'll close out of that, and then I'll go into SQL View. That's how we get into a mode where we can type our SQL queries in. So I'm going to type exactly what I have here. Select star from student. So exactly that. If I go and run it, it shows me a list of every column for every student. All right? That's about the simplest SQL statement that you can write, where you say, give me every column for every student or other table. All right? Now, you don't necessarily always want to see every column, right? If let's say, for example, I was preparing some sort of mailing labels, all right? I wouldn't care what the student's phone number was if I'm printing a mailing label, right? You don't put a phone number on a mailing label. And I wouldn't care what their date of birth was. And I wouldn't care if they're a senior, junior, sophomore, or freshman. I would only want to see these columns. All right? So, if I want to limit what columns I see, instead of using an asterisk here, I list out the columns that I want to see. So, let's say I want to see the student's first name, last name, city, and state. And that's it. I'll say select SF name, SL name, S city, S state from student. Now, what will this do? This will give me, for every student in the table, their first name, their last name, their city, and their state. Okay? So I'm reducing the number of columns I see, but I'm not reducing the number of rows. All right? I'm pulling everything from that student table. So let's go and let's enter this query in. Let me go back to SQL View. And instead of saying select star, I'm going to say select SF name, SL name, S city, S state from student. Okay? So that's exactly what I have here. If I go and run it, I'll see the same number of students I saw before, but I won't see every piece of information. All right? I'll just see the information that I was interested in for this particular report, which was their first name, last name, city, state, and zip. If you think about this, there's important security implications about this. You know, let's say, for example, I was preparing a phone directory for my organization. All right? Seems reasonable enough. Or maybe I even have, let's put it this, let me change it. Let's say I have a web page that displays a phone directory for my organization. All right? Now, where is it probably going to pull that phone directory from? Well, it's going to pull it from the employee table, right? Well, there's all kinds of stuff in an employee table, right, that ought not to be public knowledge. You know, person's salary, number of dependents a person has, spouse's name, social security number, and so on. So therefore, the query that's going to pull people's information simply to produce a web page that's a phone directory, an online phone directory for a company, shouldn't display every column in the employee table. It should only display the columns that are relevant. And so, first name, last name, phone extension maybe. Maybe their job description as well, something like that, so that you could see it. All right? So we can limit the number of columns that we display, and we can only show the stuff that's really relevant. And again, as far as security goes and privacy goes, it's a good thing to be able to do that, because if you're giving reports to people, you don't necessarily want to give them information that they're not authorized to see. So, again, the word select, the list of columns. There's commas between each column, except for the last one. There's not a comma after the last column. The commas are just there to separate each column. We then have the word from, and then we have the table that we're pulling it from. Yes? I don't think so. I think the comma would be enough. I usually put spaces just to make it more readable, but I should be able to go in and run it all together. In other words, if I go in the SQL view here, it gives me the same thing. Now I need the spaces between the words so it knows that that's from instead of from student, Yes?
Say you're dealing with a database.
Yes.
And you want every table except for two. Instead of writing out 18 tables,
Yes.
SQL code, are you able to do all minus just the two to save your keystrokes?
No. The question was, is there a shortcut to get like all the tables or all the tables except for two? And the answer is no. For column names, you either specify that you want all columns, or you list each column that you want individually. For table names, you have to always just list the tables that you want individually. There's no wild cards with tables. There's a wild card for columns where you say, give me every column. Or you can, enumerate the ones that you do want. But with tables, you always have to list the tables that you want. So if you want 3 tables, you have to say table A, table B, table C. All right? Now, if we don't specify otherwise, it will appear, this list of students will appear essentially in whatever order the database feels like giving it to us. All right? It might sound goofy, but it really depends on the specific database we're using and how it feels like giving it to us. Access will give it to us in primary key order. All right? However, you can't count on that. If we were using another database, we could get it in some seemingly random order that we would have no idea. It might be the order that the students were entered in, for example. All right? Therefore, if you want to control the order that your rows appear in, you need to add an order by clause. All right? We speak in terms of clauses in SQL. All right? So far we've seen one clause, the from clause. Now, when I start putting these clauses down, these clauses have to appear in the order that I'm going to show them. So you can't switch the order of the clauses around or it won't work. So, the clause to sequence our list of rows is the order by clause. And with the order by clause, we can specify a list of fields that we want to sort by, similar to what we did in the query by example. So if I want the same list, but I want it sorted in alphabetical order, I could say select SF name, SL name, S city, S state, from student, order by SL name, comma, SF name. What that will do is it will sort first by their last name. And if there's any ties for last name, if there's any two people that have the same last name, it will sort those by their first name. So let me go in. Let me go into my student table. And let's add a second Miller. We'll add Frank Miller to that. All right? So now if we look at the query that we have, I'll go back into SQL view, and I'll put in exactly what I have here, which says select SF name, SL name, S city, S state, from student, order by, SL name, SF name. If I go and run that query, I just typed in what I had written on the paper. If I go and run that query, notice again that Frank Miller appears before Sarah Miller. All right? They're in alphabetical order, so the B is the first one, the C is the second one, D, M. But where there's a tie, the tiebreaker, so to speak, is the first name. And that's because I said sort first by SL name, by their last name, and then sort by first name. So it will sort by last name, and if there happens to be two people with the same last name, it will sort them in sequence according to their first name. Yes?
Now, if you were to move the order by the second line underneath the select line, does that change the query at all?
Yeah, the query doesn't work. All right?
So it has to run.
It has to, yeah, the clauses have to be in that sequence. So, for example, if we were to say this, it freaks out and gives us an error. If you switch. What I did is I
meant,
okay.
you put order by on the second line underneath select, we keep from behind SS state.
Oh. All on one line?
No, that's it. Just like that.
Yeah, that's fine.
That's fine.
Yeah.
So it doesn't all have to just run on.
No, it doesn't have to be all on one line going across. I'm sorry, I misunderstood you. I thought you meant switch the order of the clauses. Yeah. What you do, again, with this, you can write it whatever is going to be readable for you. So, in other words, what often I'll do is I'll put each clause on its own line. I guess it depends if it's a long SQL statement or a short SQL statement. You know, I can write, however I write it out, it doesn't really matter if it's on the same line or different lines. Now, yes, go ahead.
As you're writing your SQL statements, are you able to comment in there just in case multiple people are working on a database, and or are you able to, well, basically just comment so you can remind yourself what you did and why you're doing it?
That is a great question. The question is can you comment that? If you are writing, keep in mind, if you're writing these SQL statements, you're usually writing them embedded in some programming language. So if that was the case, what you would do is you would put in your program the comments that would explain what you're doing at that point. In this case, within Access's query by example, I'm not sure. Another place where you can use SQL statements are not in Access, but in other databases. They have what are called stored procedures. Stored procedures are like little mini database programs, and you can comment those as well. I don't know if Access's QBE will allow you to put a comment in. Well, we can try. If we were able to put a comment in, it would probably look like this. That don't work. Or the other common one is // and that don't work either. So I don't think within Access's query tool you can do that. But if you were incorporating this into PHP or something, then you could do that. Or if you're using a database that supports stored procedures, you'd be able to do that. Good question. It's always good to explain. Readability and the ability to understand really what's going on is key to writing code that's easy to maintain. All right. So that's an excellent question. By default, this is going to be sequenced in ascending order, in increasing order. So A is considered to be the smallest letter in the alphabet. Z is considered to be the highest. So this would go from A to Z. All right. That's by default. You can also explicitly say either ASC or DESC in your select statement. So, for example, I could say order by SL name DESC, SF name DESC, and then it would do in reverse order. All right, the Z's would be on top because it's descending order, down through the A's. And if there's a tie for last name, then the higher last name would be above the lower last name. So let me go and do that. And there, the U's on top, the B's on the bottom, and Frank is still before Sarah? I put ASC. Oh, okay. Good eye. I intended to put DESC. There we go. Now Sarah's above Frank. If you want ascending order, it would be ASC. If you don't put anything, it's assumed to be ascending order, so ASC. Now for letters, it's alphabetical order. For numbers, it would be numeric order. For date, it would be chronological order, and so on. Generally makes sense, the order that they appear. We still are always seeing every student, though. All right? All these queries that we've been looking at, we've still been seeing every single student. What if we only want to filter students to see students like we did in the query by example that were in a specific city, that were in Eau Claire, let's say? Well, that's where we need the where clause. That's the last clause that we'll look at tonight. And then we'll pick up on this Tuesday. But I do want to introduce you to the where clause, and we'll talk more about that next time. All right. So, I've added the where clause, and what the where clause does is it filters out rows. All right. So, to break down this SQL statement, starts with the word select. Always starts with the word select. Has a list of the columns that we want. the from clause, followed by the tables that we're using that contain those columns. So this is the columns. This is the table that has those columns. The where clause then filters out the stuff that we want. And in this case, I want those students whose city, S-city, equals Eau Claire. Now, if you notice Eau Claire's in quotes, that's because it's not a column in a database. There's not a database column called Eau Claire. We actually want to make sure it's equal to that specific value. And then finally, order by, and we specify the sequence. Now, these clauses will always appear in this order. Select, from, where, order by. All right, so you can't vary that up at all. All right, one might be missing. All right, specifically the where or the order by could be missing. Maybe you really don't care the order it's in, so you don't put an order by. Or maybe you really do want everything, so you don't put a where clause. But if you have them, they appear in this order. We'll introduce a couple more clauses next time, and we'll see where they sort of fit into the picture. But again, what can we do? We can limit what columns they see. We can specify what table. We can limit what rows, and we can order the results. So next time we'll continue looking for a little while anyhow on single table queries, and then we'll get into multiple table queries. For example, there's a lot of ways that where clauses can be written. This is probably the most straightforward one, where one column equals that. But you can have all sorts of things, like you can have combinations of conditions. Maybe, for example, I only want to see freshmen from Eau Claire, in which case I have a compound condition. We'll pick up on that next time. Maybe I want to look up someone by name, but I don't know their whole name. I just know the first part of their name. That also can be handled via the where clause. All right, so next time we'll talk more about single table queries, and we should get into multiple table queries. All right, we'll see you over in lab.